What we're going to be working on today is properties of logarithms. So first we're going to go through the properties and then we're going to use them to expand and compress logarithms. The first one is the product property. And it says if you have a log with any base and you're taking that log of a product of m times n, then you can separate that into two separate logs that would also be base b, and it becomes an addition problem. So it would be log base b of m plus log base b of n. So the product of an argument becomes the sum of two separate logs. The quotient property goes right along with that, and it says if we have the log of any base of a quotient of two arguments, m divided by n, then that's going to become the difference of two logs, log base b of m minus log base b of n. The power property deals with a logarithm in which the argument is raised to a power. So if we have log base b of m raised to the n power, what we can do with that power is we can bring it to the front of the logarithm and it becomes a coefficient of the log. So we would have n times log base b of m. Change of base formula allows you to change your base from anything you started with. So we'll start with log base b of m, and we're going to change it to anything we want. So we're going to change that to log base c, just to indicate it could be any number. So it would be log base c of m divided by log base c of b. Notice that the change of base formula is the only one that ends up dividing two logarithms. This one is one log with a divided argument, separates into subtraction. So we use that change of base formula to change to any base we want, but it's often most useful to change to something the calculator understands, and there's only two of those, as we'll see later. So what we're going to do now is use the properties to express the logarithm as a sum or difference of logarithms, which means we are expanding the logarithm. Now I have kind of a goofy story that actually works with all of these properties, and it's excuse me, it's kind of how I think of separating these logs out. And it's here, and it's basically that you have roommates living in a single log, like an apartment building or something. Each roommate, which is separated by walls of multiplication, is going to move into his or her own log home. The upstairs folks end up living in positive log homes, and the downstairs folks end up living in negative log homes. So once they move into their own home, they can unpack their exponent out to the front of the logarithm. So when we look at this log, log base 7 of 3x squared divided by 2, we can see that in the upstairs we have 3 times x squared. So that would be 2 roomies upstairs. And in the basement we have just one number, so there's only one roomie. So when we move these into their own spaces, we are going to need 3 log homes. Now these 3 log homes are going to keep the same base of 7. So I'm going to write log base 7, log base 7, log base 7. Remember that the upstairs roomies end up being positive. So I'm going to have log base 7 of 3, which is positive because there's nothing out front, plus log base 7 of x squared. And then the downstairs roomie ends up negative, so I have minus log base 7 of 2. Now once they've all moved into their own log homes, we can use that power property to bring this exponent on the x squared out to the front. So we would end up with the answer to this problem being log base 7 of 3 plus 2 log base 7 of x minus log base 7 of 2. Now none of these are like terms, because for them to be like terms they would have to have the same base and the same argument. And these all have different arguments. So this would be our answer. Let's practice a couple questions. Down here, this example here. We want to look and see how many roomies we have upstairs, how many roomies we have downstairs, and that's going to tell us how many new log homes we're going to need. So here I have 1 positive roomie and 2 negative roomies. So I'm going to need 3 log homes again. And this time they don't have any base written, which means that it is base 10 because it's a common log. So I'll expand this into log of x, which is positive, minus log of y, minus log of z. Now I check to see, do any of my former roommates have things to unpack in their exponents? They do not, so this would be the answer to this question. Log base 3 of 7 times 2z minus 3 squared. You have to look for the multiplication in this problem. It is multiplied right here between the 7 and the parenthesis. The 2z minus 3, that cannot be separated. So we're just going to treat it like its own roomie. So in this case, since there is no denominator, I have 1, 2 upstairs roomies. So I'm going to need 2 logs that are base 3. So I'll have log base 3 of 7 plus log base 3 of 2z minus 3 squared. Now we want to check to see if anyone has anything to unpack. The 7 has an exponent of 1, so we don't need to unpack that. But this parenthesis has an exponent of 2, so we can unpack that to the front. So then we have log base 3 of 7 plus 2 log base 3 of 2z minus 3. Now we cannot separate the 2z minus 3, and they have to stay in parentheses. So it's really important to not separate them and also keep them grouped in parentheses so that everyone can tell that it's all inside that logarithm. Now we would want to look at log base 3 of 7, and we want to remember that log base 3 of 7 asks the question 3 raised to what power gives you 7. 3 raised to no power gives us 7. Well, no whole number, so you leave it because it cannot be simplified. Okay, let's do some that are a little bit more interesting. Log base 8 of 8 times the square root of 3a squared. The first thing that I would want to do in this problem is rewrite my 3a squared inside that radical with a fractional exponent. So I'm going to rewrite this as log base 8 of 8 times 3a squared to the 1/2. And then remembering about exponents, that means that I can apply this power of 1/2 to the 3 and to the a squared. And remembering that I multiply my exponents when I raise a power to a power, that's log base 8 of 8 times 3 to the 1/2 times a to the 2 times 1/2 just gives me a to the 1. So I would just leave that as a with no written exponent, which means it's an exponent of 1. Now I can move them into their own log homes. You can see that there's a denominator of 1, so all my roomies are upstairs, and I have 1, 2, 3 of them. So I'll need 3 log homes that are base 8. So that will be log base 8 of 8 plus log base 8 of 3 to the 1/2 plus log base 8 of a. Now that they're all moved out, I can check for unpacking. 8 doesn't have any exponent other than 1, so it doesn't need to unpack. 3 has an exponent of 1/2, so that will go down to the front. And a, again, has an exponent of 1, so we'll leave that. And while I'm unpacking this 1/2 to the front, I'm going to look at log base 8 of 8. Can it simplify? Remember the question that it's asking you is 8 to what power gives me 8? And of course we should know that 8 to the first power gives us 8, so log base 8 of 8 would be equivalent to 1. So I'll just replace that with a 1 plus 1/2 times log base 8 of 3 plus log base 8 of a. And there's nothing else that can be simplified because this log is asking me 8 to what power gives me 3, which there is no answer that we can come up with in our heads, so we would leave it like that. Alright, this one looks more complicated still. And I'm glad to see that it has some upstairs and downstairs roomies. I think I'll go ahead and start like I did the other one by rewriting that radical in exponential form. So that's going to give me log base 7 of x plus 9 to the 1/2 over s squared t to the 1/3. Now the x plus 9 cannot be separated, and I also can't take the square root of the 9 because it's added to the x. So I have to leave the x plus 9 in the parentheses to the power of 1/2. And then I can start looking at how many roomies do I need. I have 1 upstairs and I have 2 downstairs. So I'm going to need 3 logs. 1 will be positive, 2 will be negative. So I'm going to have log base 7 of x plus 9 to the 1/2, which is positive, minus log base 7 of s squared, and then also minus log base 7 of t to the 1/3. Now that they're all moved out, we can go ahead and start unpacking. So I'm going to unpack my power of 1/2 down to the front, unpack my power of 2 down to the front, unpack my power of 1/3 out to the front, and I'll have 1/2 log base 7 of x plus 9 minus 2 log base 7 of s minus 1/3 log base 7 of t. Now remember that x plus 9 cannot be separated, so I cannot do any other simplifying on that, and this ends up being my answer. Okay, now we're going to reverse the process, and we're going to write these expressions as a single logarithm. So we're then taking 2 separate households and we're going to combine them into a single household. Now they have to have the same base, so this actually is a typo. That should be log base 2. They have to have the same base before they can move in to the same log building. So what we have to do first before they move in is they have to pack up. So anything that's out front is going to go up to the exponent. Then they're going to move into a single log building. Remember that the positive roomies go upstairs and negatives go downstairs. So in this problem here, we have one that is positive and will be upstairs, and we have one that is negative and will be downstairs. So we're going to have a single log with an upstairs and a downstairs. The positive argument goes upstairs, the negative argument goes downstairs. Once they're moved in together, we can simplify this 9/3. So this ends up being log base 2 of 3. And then remember to ask yourself the question, 2 to what power equals 3? And if there's not an answer that we can readily come up with, then we're just going to leave it because it wouldn't simplify. So this right here will be our answer. Okay, next example. Remember that before we start moving in, we have to pack up. So this exponent, or this coefficient of 5, is going to become an exponent on the 3. This one doesn't have a coefficient, so we move on to the next, and we just take the 2 and make it an exponent to the x. So now we've got log of 3 to the 5th plus log of 4 minus log of x squared. Then we're going to move the positive logs become upstairs roomies, negative logs become downstairs. So we're going to have one single log, and we're going to have 2 upstairs that we multiply by each other. So it's 3 to the 5th times 4, and then we have x squared in the denominator. Now we could go ahead and simplify this because 3 to the 5th is multiplying 3 5 times, which comes out to be 243. And then we can take that times 4. You'll want a calculator for that, I'm guessing. And it comes out to be 972 over x squared. Excuse me. Let's see if we have more examples. Oh, looks like we do. Log base 4 of 48 minus 1/2 log base 4 of 9. So we're combining these to a single log, which means things have to get packed up. So I'm going to pack up this 1/2 to the exponent of 9. So I've got log base 4 of 48 minus log base 4 of 9 to the 1/2. Now I remember that 1/2 exponent. A 1/2 exponent means a square root. So 9 to the 1/2 is the square root of 9, which simplifies to a plain old 3. So I'm really doing log base 4 of 48 minus log base 4 of 3. Now my stuff is all packed up, so I'm ready to move into a single log. So I got log base 4 of positive goes to the numerator, so 48, negative goes to the denominator over 3. And then I can simplify 48 divided by 3, which is log base 4 of 16. Now that log is asking me a question. It's asking me 4 to what power gives me 16. Now this one does have an answer. 4 squared is 16. So we would need to replace log base 4 of 16 with 2, and that would be our answer. On to the change of base formula. To change our base, we're going to use that formula that was log base b of m equals log base c of m over log base c of b. Now what's handy about this formula is that the m and the b, like the m looks higher in the formula than the b does, and when you go to the other side, the m is in the numerator and the b is in the denominator. So that's how I remember which one is up and which one is down. We could choose any base we want, but it's most convenient if we choose one that our calculator knows how to deal with. And there's only two of those. One is the common log, which is base 10, and the other is the natural log, which is base E. And there's buttons on your calculator for those. It's LOG and LN. So on these problems, it really is as simple as rewriting these logarithms and then punching them in your calculator. So we'll go ahead and start with this one, log base 2 of 9. And we're going to change that to, let's just go with a natural log because it's less writing. So it would be the natural log of the big number 9, and when I say big I mean like tall, divided by the natural log of 2. And then you just go to your calculator, if I can get mine to turn on, and we type in the natural log of 9 divided by the natural log of 2, enter, and we get a numerical value 3.1, we'll just round to the nearest hundredth, 3.17. Now just for funsies, we'll do the other one to common log. So that will be the common log of the tall number 62 divided by the common log of the base, which is 5. And that button is next to the 7. So we take the log of 62, and you can hit enter if you'd like, and then hit divide by log of 5 and hit enter, and that's about 2.56. Now I do want to show you that it's exactly the same no matter which log you choose. So let me rework this one with a natural log of 62 divided by a natural log of 5. The natural log button is next to the 4. So we'll do natural log of 62, enter, divide by natural log of 5, enter, and you can see that we get the exact same number, 2.56.